Welcome to part 5 of lesson 1, argument. Consider the complex number z1 is equal to 3 plus 2i. Its point P in the Argand diagram is 3, 2. Plot z1 by moving 3 units to the right of the origin and then up 2 units. Call A the angle z1 makes with the positive real axis. Positive angles are always measured in an anti-clockwise direction from the positive real axis. The angle A is called the argument of z1, denoted as arg z1. Calculate A using tan. Tan A is 2 over 3. So the argument of z1 is the inverse tan of 2/3. Therefore, A is the inverse tan of 2/3, which works out to be 33.7 degrees. Consider a related complex number z2 is equal to minus 3 plus 2i in the second quadrant. Call its point q minus 3, 2 in the Argand diagram. Plot z2 by moving 3 units to the left of the origin and then up 2 units. Once again, call A the angle z2 makes with the positive real axis. Positive angles are always measured in an anti-clockwise direction from the positive real axis. The angle A is now called the argument of z2. The angles marked theta are equal as they occupy similar positions in identical triangles. A is equal to 180 degrees minus theta, or pi minus theta, where theta is equal to the inverse tan of 2/3, or the inverse tan of the absolute value of 2 over minus 3. Consider a related complex number z3, which is equal to minus 3 minus 2i in the third quadrant. Call its point or minus 3 minus 2 in the Argand diagram. Plot z3 by moving 3 units to the left of the origin and then down 2 units. Once again, call A the angle z3 makes with the positive real axis. Positive angles are always measured in an anti-clockwise direction from the positive real axis. The angle A is now called the argument of z3, which is equal to 180 degrees plus theta, or pi plus theta, where theta is the inverse tan of 2/3, or the inverse tan of the absolute value of minus 2 over minus 3. Lastly, consider a related complex number z4, which is equal to 3 minus 2i in the fourth quadrant. Call its point in the Argand diagram S 3 minus 2. Plot z4 by moving 3 units to the right of the origin and then down 2 units. Once again, call A the angle z4 makes with the positive real axis. Positive angles are always measured in an anti-clockwise direction from the positive real axis. The angle A is now called the argument of z4, which is equal to 360 degrees minus theta, or 2 pi minus theta, where theta is the inverse tan of 2/3, or the inverse tan of the absolute value of minus 2 over 3. Generalize the process where z is equal to a plus bi, which can also be written as z is equal to real part plus imaginary part times I. Plot z in an Argand diagram with PAB representing z. Call theta the argument of z. We define theta to be the inverse tan of the absolute value of the imaginary part over the real part. Taking the absolute value takes care of any negative signs where z is in other quadrants. Now you are able to work out the argument of any complex number a, no matter what quadrant it is in. A is equal to theta if the complex number is in the first quadrant. A is equal to 180 degrees minus theta, or pi minus theta, if the complex number is in the second quadrant. A is equal to 180 degrees plus theta, or pi plus theta, if the complex number is in the third quadrant. And finally, A is equal to 360 degrees minus theta, or 2 pi minus theta, if the complex number is in the fourth quadrant. Now let's find the argument of z of some complex numbers, starting with z is equal to minus 3 plus 5i. Identify in your head what quadrant z is in. Z is in the second quadrant. The argument of z equals 180 degrees minus the inverse tan of the absolute value of 5, which is the imaginary part, over minus 3, which is the real part. The answer is 121 degrees to the nearest degree. Next, find the argument of z in radians, or rads, if z equals minus a half minus root 3 over 2i. Z is in the third quadrant. The argument of z equals pi plus the inverse tan of the absolute value of minus root 3 on 2 over minus a half. Change the calculator to radians mode. The argument of z works out to be 4/3 pi radians. Let's do a construction example. Example 1. Plot the complex number z, where the absolute value of z is equal to 3, and the argument of z is equal to 120 degrees. The modulus of z is 3. Put the point of the compass at the origin and stretch the pencil 3 units along the x-axis, or the real axis. Draw a circle of radius 3. Place a protractor with its center on the origin. Go to 120 degrees anti-clockwise from the positive real axis and mark a point on the graph paper. Draw a line from the origin through this point until it intersects the circle. This point of intersection is Z. That's the end of the lesson on arguments. Complete the exercise 1.5 on this topic.